The morning of March 20th, 1944, at the Detroit ordnance plant, a steel monolith of a gun barrel gleamed under the fluorescent lights. Workers adjusted the hoists, aligning the rifling inside the muzzle with painstaking care. Each measurement verified twice, 3 times over. The engineers had nicknamed it the 89-9 as a joke in early sketches, its caliber rounded up from a precise 90 millimeters, but the men on the assembly floor knew this was no trivial weapon. This barrel was a promise, a single, resolute answer to the German war machine. Within its bore, a shot fired at 3,000 feet could pierce the frontal armor of the Tiger I, a tank that had until then seemed invulnerable on the Western Front. By 1944, the Tiger was legend. For the German Panzerwaffe, the Panzerkampfwagen V6 Tiger I represented the culmination of armored doctrine: 80 mm frontal plates, an 88 mm gun that could annihilate any Allied tank at ranges over 1,000 yards, and a psychological reputation that cast fear into infantry and armor alike. Western Allied intelligence, initially skeptical of German claims, had now confirmed through battlefield reports and captured documents that a single Tiger could stall entire advances. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. In Normandy, in Italy, in the hedgerows and forests of France, American and British tank crews learned the same brutal lesson. The Tiger could engage from beyond effective return fire, its frontal armor almost impervious to the 90 mm guns then mounted on Sherman tanks. Losses mounted, and with them, a growing sense among the armored forces that no available Allied gun could reliably defeat the Tiger's armor. This belief that no domestic weapon could neutralize the Tiger had become an unspoken truth in American tank doctrine by the spring of 1944. Sherman crews were trained to rely on maneuver, numbers, and coordination with infantry and artillery, rather than superior firepower. Tankers carried extra rounds, extra fuel, extra ration packs, but they also carried a quiet, gnawing anxiety. They knew that meeting a Tiger head-on meant either outnumbering it, ambushing it, or praying. Every report from Normandy, every intercepted German communication, reinforced the idea that the Tiger was nearly invincible. And yet, somewhere within the ordnance depots of the United States, engineers and designers refused to accept that conventional wisdom. They asked a simple, dangerous question. What if we could build a gun that made the Tiger's armor irrelevant? The story of the American 90 mm gun begins not on a battlefield, but in a series of drawing rooms and testing grounds scattered across Detroit, Philadelphia, and Aberdeen proving ground. By early 1944, the Ordnance Department had been experimenting with high-velocity, large-caliber weapons for nearly 2 years. Initial trials of the T-15E1 and T-7 guns had revealed one fundamental truth: a longer barrel and a heavier projectile increased muzzle velocity, but reliability and mobility were persistent obstacles. The Germans had engineered the Tiger with not just armor but tactical foresight. Their vehicles were heavy, stable, and carried powerful suspension and drivetrain systems that allowed for calculated engagements at long ranges. The challenge for American designers was twofold. The gun had to fit on a chassis that could actually move across European terrain, and it had to be reliable under the strain of repeated combat operations. By February 1944, the Ordnance Department had settled on a plan. The T-15 series, refined into the T-15E2, promised a muzzle velocity exceeding 2,500 feet per second with an armor-piercing, capped shell capable of penetrating 120 millimeters of steel at 500 yards. For perspective, the frontal armor of the Tiger I measured roughly 100 millimeters, sloped only slightly in certain areas. The calculations suggested that a single round, fired from the new 90 millimeter gun at standard engagement ranges of 600 to 800 yards, could reliably punch through the Tiger's frontal glacis. The mathematics were simple, but translating them into a working field weapon was anything but. Mounting the T-15E2 gun required not only precise machining but the conceptual reframing of armored warfare in American doctrine. The typical M4 Sherman chassis could not absorb the recoil of a 90mm round without catastrophic structural failure. Engineers experimented with the M36 tank destroyer platform, a modified Sherman hull with a fixed casemate, allowing for a more robust gun mount and reduced turret weight. The M36's frontal armor was modest, roughly 75mm, but its survivability depended on firepower and agility rather than brute protection. Here lay the fundamental irony. The Americans accepted vulnerability in their own vehicles so that they could field a gun that would make German invincibility moot. They traded steel for certainty, trusting velocity and engineering over armor. At Aberdeen Proving Ground, in the freezing winds of early 1944, trials began. Engineers recorded each shot, each impact, in meticulous notebooks. They measured barrel stress, projectile deformation, and armor penetration. One morning in March, a T-15E2 gun fired a shell against a replica Tiger Glacis, a thick, welded slab of steel designed to simulate the exact angle and composition of the German tank's frontal armor. Observers noted the ricochet angle, the entry depth, and the velocity drop. On the fourth round, the shell penetrated cleanly, exiting the rear plate. For the engineers present, the moment was electric yet understated. No celebration, no fanfare, just the quiet, precise recording of data. Yet in that act, the psychological foundation for confronting the Tiger was being rewritten. The invincibility of German engineering was no longer absolute. It was quantifiable, defeatable, and, crucially, American. Across the Atlantic, German crews remained unaware of these developments. Intelligence reports suggested that Allied armor could not breach Tiger frontal plates beyond 500 yards. German propaganda, circulated through leaflets and radio broadcasts, reinforced this notion. Photographs of Tigers advancing through villages, their guns poised, their armored silhouettes dominating every horizon, created a perception of invulnerability that aligned with battlefield reality. The cognitive dissonance would come later, when American 90mm rounds, fired from tank destroyers or modified Shermans, punctured that carefully cultivated myth. In Normandy, by late June 1944, the first M36 tank destroyers began arriving in small numbers. Crews trained stateside, many of them veterans of earlier campaigns in North Africa and Italy, were handed new doctrine: engage Tigers at maximum effective range, prioritize weak points, and rely on precision over maneuver. Training included careful calculations of distance, armor angling, and shell selection. Tankers learned to identify turret mantlets, side plates, and lower glacis areas as targets. This knowledge represented a radical departure from prior tactics, where American crews had relied on ambush, numerical superiority, and artillery support to counter heavy German armor. The first engagements in late July and early August confirmed the engineers' calculations. Reports from the 704th Tank Destroyer Battalion, operating near Saint-Lô, detailed multiple instances where a single 90mm round penetrated the frontal armor of Tiger I vehicles at ranges exceeding 600 yards. The psychological impact on German crews was immediate and profound. Accounts from surviving diaries and post-war interviews indicate a sudden shift in confidence. Tank commanders who had previously maneuvered aggressively now hesitated, alternating between frontal engagement and cautious repositioning. Where once the Tiger had dictated the pace and positioning of the battlefield, it now contended with a weapon that negated its primary advantage. The irony was stark. The Tiger, conceived as the apex of armored warfare, became vulnerable not because of superior tactics or strategic genius, but because American engineering had focused relentlessly on a single, quantifiable variable: armor penetration. The 90mm gun did not make Shermans invincible, nor did it create a perfect battlefield solution. Instead, it reframed the conflict. The psychological dominance of the Tiger was broken by the certainty of mechanical physics, a triumph of engineering over fear. By early August 1944, the 90mm gun was no longer just a concept on paper or a test fixture in Detroit. It was a tool of battlefield certainty. The M-36 tank destroyers, equipped with the T-15E2, rolled through the muddy roads of Normandy, their crews carrying a quiet confidence rooted in data and engineering. Unlike the Sherman, which relied on speed, maneuver, and numbers to survive, the M-36 relied on precise firepower to impose its will on the battlefield. The weapon's long barrel extended far beyond the turret's front, a visible signal of the capability contained within. Crews described the gun with a mixture of awe and respect. One tanker, writing to his family from near Saint-Lô, noted the recoil as brutal, almost punishing, but precise. A single round struck the target exactly where the calculations indicated it would. Another recorded that loading required careful attention to the new, heavier armor-piercing shells, each weighing nearly 30 pounds, but that the effort was worth the assurance of destroying targets that had previously seemed untouchable. In training grounds and early engagements alike, every observation reinforced a simple principle. When properly employed, this weapon rendered the Tiger's frontal armor irrelevant. The technical sophistication behind the T-15E2 gun was substantial. The gun featured a 150-inch-long barrel, rifled with a twist designed to stabilize the heavy armor-piercing, capped APC rounds. These rounds were constructed with hardened steel cores, tipped with a soft cap to prevent shattering upon impact while still concentrating force on the armor. Powder charges were carefully measured to maintain consistent muzzle velocity of roughly 2,600 feet per second, a figure calculated to penetrate 120 millimeters of rolled homogeneous armor at 500 yards and more at shorter ranges. Precision machining of the gun mount ensured that recoil forces were absorbed evenly across the M36's casemate, reducing stress on the chassis and maintaining accuracy over repeated firings. What made the gun particularly transformative was its integration into American armored doctrine. The M36's design allowed it to position itself defensively, often behind hedgerows, in the folds of terrain, or within prepared firing positions where the gun could dominate an avenue of approach. Crews were trained to calculate engagement ranges, adjust elevation meticulously, and employ armor-piercing rounds against weak points on the Tiger. Unlike earlier confrontations, where American tankers might fire multiple rounds ineffectively at heavy German armor, the 90mm gun offered a near-certain outcome. A properly aimed shot would destroy or disable the Tiger. By mid-August, the impact of the 90mm gun became undeniable. In a series of skirmishes around the Cotentin Peninsula, American forces reported that Tiger tanks no longer dictated the pace of engagements. Units that had previously adopted extreme caution now maneuvered aggressively, supported by M36s, whose crews understood that a single shot could level the most formidable German tank. Survivors of German units, captured after these encounters, expressed a mixture of disbelief and frustration. Diaries from the period reveal that crews referred to the American gun with a mixture of respect and fear, a weapon capable of penetrating the Tiger's frontal armor at distances once thought safe. The psychological effect extended beyond individual crews to the broader operational level. German commanders, previously confident in the Tiger's ability to control open ground and support infantry, began recalculating deployment strategies. Tigers were ordered to adopt more conservative positions, to rely increasingly on ambush tactics, and to coordinate with anti-tank guns in defensive networks rather than leading assaults independently. The battlefield advantage that the Tiger had enjoyed a combination of armor, firepower, and psychological dominance was eroding under the relentless certainty of American engineering. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. One documented engagement in late August illustrates the effect vividly. Near the town of Avranches, a small American reconnaissance element encountered a pair of Tiger I tanks advancing along a narrow road. The lead M36 crew, having calculated range and angle, fired from a concealed hedgerow at roughly 600 yards. The first shot penetrated the frontal glacis of the lead Tiger, detonating internal ammunition and forcing the crew to abandon the vehicle. The second Tiger attempted to engage, but was destroyed by a follow-up shot from another M36 positioned on the flank. Contemporary after-action reports emphasized the shock among German crews. The Tiger, which had previously been a symbol of invincibility, had been neutralized almost effortlessly by what the Americans called their big gun. The effect on American morale was equally pronounced. Tank crews and infantry alike gained confidence knowing that the Tigers, once feared, could be engaged and destroyed with disciplined, precise fire. Letters from the period reflect this shift. One private wrote, "We've faced Tigers and come through. For the first time, they're not monsters, just steel." In essence, the 90mm gun rewrote the mental map of armoured warfare in the European theatre. The myth of German invincibility, cultivated by engineering prowess and battlefield success, collided with the raw, mechanical reality of a weapon designed to exploit its vulnerabilities. At the same time, engineers and ordnance officers continued refining both the gun and its integration into combat vehicles. Lessons learned from early combat highlighted the importance of crew training, sight calibration, and shell quality. The T-15E2 and its variants underwent continuous improvement. Better rifling tolerances, improved recoil management, and standardized ammunition that reduced the risk of misfires. In laboratories at Aberdeen Proving Ground and Detroit's ordnance facilities, technicians tested every aspect of the system under extreme conditions, cold, heat, repeated firing to ensure that the gun performed reliably in the unpredictable conditions of European battlefields. The irony, however, extended beyond the technical. The Tiger had been conceived as the pinnacle of armoured engineering, a combination of thick armour, a high-velocity 88mm gun, and a complex suspension system capable of supporting heavy weight. Yet, all of these advantages, structural ingenuity, firepower, and tactical doctrine, were effectively neutralized by a single, well-calculated design choice on the American side: to build a gun that did one thing extraordinarily well. The American ordnance engineers did not seek to produce a tank to rival the Tiger in weight or frontal armor. They did not attempt to match German engineering across every metric. Instead, they focused on a single parameter: creating a weapon that could reliably pierce the Tiger's armor and do so under battlefield conditions that could be reproduced consistently by trained crews. The culmination of these efforts was not simply the destruction of individual Tigers, but a shift in operational doctrine. By September 1944, the presence of the 90mm gun allowed American units to reconsider how they planned offensives. Sherman battalions could operate with greater freedom, relying on M36s to eliminate heavy German armor, while infantry units were reassured that direct armored support could now be counted upon in ways previously impossible. The battlefield, once dominated by fear of German engineering, now reflected American industrial confidence. A single, meticulously designed weapon had shifted the strategic calculus. Contemporary German reports underscore this shift. Intercepts of communication between panzer divisions indicated growing concern over the new American gun. Commanders noted that Tiger I losses were rising not due to numbers, terrain, or luck, but because of a weapon that could penetrate their frontal armor at previously safe ranges. Orders were issued to restrict Tiger deployment to urban areas, forests, and positions where long-range engagements were unlikely. In effect, the Tiger's advantage was circumscribed not by inferior strategy or tactics, but by a specific, engineered solution developed thousands of miles away. In the months that followed, the 90mm gun's legacy became increasingly clear. The M36 and other platforms armed with the T-15E2 contributed directly to the neutralization of the Tiger's battlefield dominance. Engineers documented performance, logistics officers ensured ammunition supply, and commanders recalibrated tactics based on empirical results rather than assumption. The Tiger, once a symbol of armored supremacy, was reduced to a vehicle vulnerable to a single, precisely aimed shot from an American weapon. The historical irony is profound. A tank conceived to dominate European battlefields was undone not by superior numbers, superior training, or even superior tactics, but by the relentless application of engineering rigor. Where German designers emphasized structural complexity and multi-purpose superiority, American engineers emphasized focused functionality, manufacturability, and predictable performance. The 90mm gun represented the triumph of calculated, empirical problem-solving over intimidation and reputation. By the winter of 1944, as the Allies pushed toward the Siegfried Line, the 90mm gun had established itself as a central pillar of anti-Tiger doctrine. Reports from armored units consistently emphasized the weapon's effectiveness, while German losses mounted correspondingly. Survivors of Tiger units, writing after the war, reflected on the psychological shift. The invincible tank had become just another target, subject to the unyielding logic of American engineering. The story of the 90mm gun is thus not merely a tale of technology, but of psychology, doctrine, and human ingenuity. It demonstrates how focused engineering, grounded in empirical testing and relentless iteration, can overturn entrenched assumptions of battlefield superiority. By concentrating on one objective, penetrating the Tiger's armor, the American Ordnance Corps achieved disproportionate impact, rendering a legendary weapon vulnerable and shifting the balance of confidence on both sides of the conflict. By the closing months of 1944, the consequences of the 90mm gun were no longer subtle or isolated. Reports from the Western Front, particularly during the battles in the Ardennes and along the approaches to Aachen, demonstrated a new battlefield reality. The Tiger, long considered the apex of armored warfare, had been stripped of its psychological and tactical supremacy. Units once held in reserve to counter the feared German heavy tanks were now deployed more confidently, often spearheading advances where previously caution had been paramount. The operational impact of the weapon was quantified meticulously. The M-36 tank destroyer, armed with the T-15E2, achieved kill ratios against Tiger I and E vehicles, far exceeding those of conventional Sherman units. In reports from the Ninth Army, anti-Tiger engagements accounted for over 70% of all heavy German tank losses in certain sectors. Casualty rates among American tank crews remained lower than anticipated for such confrontations, demonstrating that the gun had not only shifted mechanical balance, but also mitigated the extreme risk associated with facing German heavy armor. German units, conversely, experienced a profound erosion of morale. Diaries and post-war interviews reveal that Tiger crews, once confident in their vehicle's dominance, increasingly feared engagements with American forces, even at ranges previously considered safe. One Tiger commander, writing in his memoirs after capture, recalled, "We had thought ourselves untouchable. The Allies' new gun made our armor nothing more than paper at a distance. We could not maneuver with the certainty we had relied upon. Every engagement carried the terror of instant destruction." The shift was not purely psychological. The strategic doctrine of the Panzerwaffe had emphasized concentrated armored thrusts, heavy reliance on the Tiger for breakthrough and holding actions, and close coordination with artillery and infantry to maximize the tank's effectiveness. With the emergence of the 90mm gun, these strategies required adaptation. Commanders increasingly dispersed Tigers, relied more heavily on terrain to mitigate exposure, and prioritized concealment over offensive maneuver. Essentially, the tactical framework that had justified the Tiger's production and deployment was undermined by a weapon that had been meticulously engineered to exploit a single, previously unassailable advantage. The gun's impact was amplified by its integration into broader American industrial and logistical capacity. The 90mm gun, mounted primarily on the M36 and select Sherman variants, could be produced rapidly and in quantity. Unlike the Tiger, which was labor-intensive and expensive to manufacture, the American approach combined mass production principles with engineering precision. By the end of 1944, hundreds of M36 tank destroyers had entered service, each carrying the capability to neutralize heavy German armor at ranges that preserved crew safety. The industrial advantage was decisive. Germany could not match the production of these weapons with vehicles that carried comparable firepower. Field reports consistently emphasized that the presence of the 90mm gun changed not only engagement outcomes, but also the calculus of American unit confidence. Tank crews no longer relied solely on numerical superiority or ambush tactics. They possessed a weapon whose reliability and destructive power allowed for aggressive maneuver, coordinated attacks, and operational flexibility. This represented a profound shift from the psychological inertia that had previously governed Allied armoured doctrine. Where once fear dictated positioning and engagement, engineering certainty now informed tactics. Historians have noted that this combination of technological innovation and industrial capability was emblematic of the broader American approach to armoured warfare in the European theatre. Whereas Germany emphasized technical superiority in isolated platforms, the United States prioritized weapons that combined effectiveness with reliability and production scalability. The 90mm gun exemplified this philosophy. It did not attempt to surpass every German tank attribute, but instead focused on defeating the Tiger's primary defensive advantage, its armor. This focus, combined with robust production and disciplined deployment, produced a disproportionate effect on the battlefield. The long-term legacy of the 90mm gun extended beyond immediate combat outcomes. Post-war armored doctrine in the United States incorporated lessons learned from these engagements. Future tank designs, such as the M26 Pershing, integrated high-velocity main guns capable of defeating heavy armor, reflecting the empirical insight that firepower, when paired with accuracy and mobility, could dictate operational outcomes more reliably than armor alone. In essence, the American experience with the T-15E2 and its platforms informed a generation of engineers and military planners who would shape Cold War armored doctrine. The weapon also had an enduring psychological imprint. Accounts from German veterans underscore that the Tiger's symbolic power, its reputation for invincibility, was irreversibly diminished. Soldiers and officers alike recognized that engineering innovation, rather than sheer numbers or tactical ingenuity, had overturned the battlefield advantage long assumed to be immutable. As one post-war report summarized, "The American gun did not merely destroy our tanks, it destroyed our certainty." The psychological supremacy of the Tiger was broken by a single, well-engineered solution. The historical irony of this outcome mirrors other examples of American engineering triumph in World War II. Just as Frank Caldwell's propeller transformed air combat by challenging conventional assumptions, and Chrysler's production innovations turned tank manufacturing into an industrial weapon, the 90mm gun redefined armored engagement by demonstrating that focused, precise engineering could neutralize even the most formidable adversary. Each case illustrates a pattern. Careful analysis, empirical testing, and relentless attention to mechanical reality can achieve outcomes that traditional doctrine, fear, or reputation cannot. By January 1945, American armored forces in Europe had fully integrated the 90mm gun into offensive and defensive operations. Tactical reports indicate that German heavy tank units were increasingly constrained to defensive roles, avoided open terrain, and were relegated to supporting infantry rather than leading breakthroughs. This operational shift was directly attributable to the confidence imparted by the gun's presence and performance. In practical terms, the weapon had rewritten the operational environment for both sides. Reflecting on the significance of the 90mm gun, one sees more than a simple story of technical innovation. It is a study in the interplay between engineering, industrial capacity, psychology, and doctrine. The gun's designers understood that victory would not be achieved by matching the enemy across all dimensions, but by identifying the decisive factor, the armor of the Tiger, and ensuring it could be overcome reliably. They tested relentlessly, integrated the weapon with appropriate platforms, and deployed it within a system that maximized its effect. In doing so, they demonstrated a principle that resonates beyond World War II. Precise engineering, when aligned with operational and psychological realities, can overturn assumptions that seem unassailable. The final months of the war confirmed this principle. Tigers continued to fight, but their battlefield dominance had evaporated. Reports from February and March 1945 describe engagements where the mere presence of American tank destroyers with 90mm guns dictated German movement, forced defensive postures, and limited offensive opportunities. The legend of the Tiger, forged through technical achievement and battlefield success, was permanently diminished not through massed numbers, overwhelming infantry, or strategic genius, but by a focused, well-engineered weapon. In the broader narrative of World War II, the 90mm gun exemplifies a recurring theme. American victory often depended less on brute force or tactical cunning, and more on systematic, empirical problem-solving applied to the realities of combat. It reminds historians, engineers, and military planners that the decisive edge often lies not in emulating the enemy's strengths, but in identifying vulnerabilities and exploiting them with precision. The Tiger was defeated not by luck or overextension, but by a calculated intervention in its fundamental defensive advantage, a lesson in engineering psychology as much as mechanics. By the time the European theatre drew to a close in May 1945, the 90mm gun had earned its place in the annals of World War II. It was neither the largest nor the fastest weapon developed by the Americans, but its effectiveness against the most feared German tank symbolized the convergence of ingenuity, discipline, and industrial capacity. The story of the gun, like those of Caldwell's propeller or Chrysler's tank production, demonstrates the transformative power of engineering applied with foresight and precision. The Tiger, for all its technical brilliance, had met its match not in numbers nor in tactics, but in a weapon conceived, tested, and deployed to exploit its one critical weakness. And in that fact lies the enduring lesson. In war, as in engineering, the decisive advantage rarely comes from perfection across every metric. It comes from identifying the decisive variable, mastering it, and applying it with unwavering rigor. The 90mm gun, quietly forged in ordnance plants, tested in proving grounds, and brought to life on European battlefields, embodies this lesson with absolute clarity. It did not merely threaten the Tiger. It redefined armoured warfare and demonstrated the capacity of focused, empirical engineering to overturn assumptions that once seemed immutable. By the spring of 1945, the European battlefields were littered with the wreckage of a war fought with unprecedented intensity, ingenuity, and brutality. Among the smoking ruins of villages, shattered bridges, and pockmarked forests, one truth had crystallized with stark clarity. The Tiger, once the terror of every Allied tank crew, had been rendered vulnerable not through overwhelming numbers or massed artillery, but by the singular, focused brilliance of a single weapon, the 90mm gun. For the men who operated it, the gun represented more than technical superiority. It was reassurance in steel. Tank crews who had trained relentlessly at Fort Knox, in Michigan, and at the deserts of Aberdeen, knew the meticulous calculations behind every round, the painstaking quality control of every shell, and the iterative design refinements that had ensured reliability under combat conditions. Unlike earlier encounters with the Tiger, which had been marked by fear, hesitation, and improvisation, engagements in late 1944 and early 1945 reflected a profound confidence. Crews could aim, fire, and destroy, knowing the result was more than likely. It was certain. Letters sent home from these crews capture the psychological transformation. One sergeant, stationed near Metz, wrote, "We've faced the Tiger again. This time, I didn't hesitate. The gun did its work, and the tank was gone. For the first time, it feels like we have the upper hand, not just in numbers, but in certainty. We no longer fight monsters, we fight machines and we can beat them." This shift was more than symbolic. American armored doctrine evolved rapidly to exploit the new reality. Where once Sherman units relied on maneuver, camouflage, and numerical superiority to survive Tiger engagements, they now coordinated directly with M-36 tank destroyers to deliver pre-planned, precise strikes. Combined arms operations incorporated the 90mm gun into integrated plans, with artillery, infantry, and engineers supporting its deployment, while reconnaissance identified optimal firing positions. The gun's capabilities shaped not only the outcome of individual skirmishes, but the structure of offensive campaigns. German responses, recorded in post-war interrogations and captured operational reports, underscore the magnitude of the shift. The Tiger, previously employed as the spearhead of armored assaults, was increasingly restricted to defensive positions, concealed flanks, and ambush tactics. Commanders recognized that direct confrontation with American forces carrying the 90mm gun was likely to result in immediate destruction. One captured officer reflected bitterly. "We were trained to fear nothing but failure. Yet here was a weapon we could not outmaneuver, outgun, or withstand. It was precision, not weight or armor, that defeated us." The irony is unmistakable. German engineers had designed the Tiger to be the apex of armored warfare: thick frontal armor, superior firepower, and an imposing presence that dominated the battlefield. And yet, despite its brilliance, the vehicle's dominance rested on a single assumption that no Allied weapon could reliably pierce its armor from a distance. The 90mm gun shattered that assumption. By focusing on the Tiger's critical vulnerability, American ordnance engineers bypassed the broader arms race in weight, speed, and complexity. They created a decisive edge not through general superiority, but through precise, empirical problem-solving. The design and deployment of the gun were themselves a testament to industrial and engineering discipline. At Aberdeen Proving Ground, rigorous tests under extreme temperatures and repeated firing conditions validated its reliability. Engineers ensured that each shell, each rifled barrel, and each mounting bracket conformed to specifications that could be reproduced in thousands of units. Production lines, in Detroit, Grand Rapids, and elsewhere turned out M36 tank destroyers and ammunition with remarkable consistency, enabling the Army to sustain operations with a level of reliability previously unthinkable against German heavy tanks. This intersection of engineering, production, and battlefield application embodies a broader lesson about World War II and modern warfare. Success often hinged not on the most elaborate technology, but on the disciplined application of practical, verifiable solutions. The 90mm gun did not seek to outmatch the Tiger in every characteristic. It did not need to. It needed only to exploit one known weakness, and in doing so, it achieved disproportionate impact. It shares lineage with other decisive innovations of the era. Frank Caldwell's propeller, Chrysler's tank assembly lines, where focused engineering, disciplined testing, and industrial scale solved seemingly insurmountable problems. The consequences of the gun extended beyond immediate tactical outcomes. By diminishing the Tiger's battlefield dominance, it altered operational planning across entire theaters. American and Allied commanders could allocate forces more aggressively, knowing that the presence of 90mm guns mitigated the risk posed by Germany's heaviest tanks. The psychological liberation of crews, the ability to plan offensives with confidence rather than fear, and the capacity to sustain pressure on German lines collectively contributed to the accelerating collapse of Nazi defensive positions in France, Belgium, and the Rhineland. The human dimension of this story is equally striking. Behind every M36 and 90mm round were engineers, production workers, and ordnance officers whose work was invisible to the soldiers on the front lines. Factory floors hummed with activity, machine operators and assemblers, maintaining tolerances measured in thousandths of an inch, all while knowing that the output would directly influence survival on European battlefields. These ordinary Americans, technicians, laborers, and engineers participated in a war effort where meticulous attention to detail translated into the defeat of some of the most feared vehicles ever constructed. Their work was mechanical, precise, and unglamorous, yet it wielded strategic power equivalent to armies. Post-war analysis consistently underscores the significance of the 90mm gun. Military historians have cited it as a turning point in anti-Tiger tactics, emphasizing that the American approach of pairing industrial capacity with empirical engineering allowed forces to neutralize qualitative advantages held by German heavy armor. Veteran memoirs reinforce this point. Crews repeatedly noted that the psychological impact of possessing a weapon capable of reliably destroying the Tiger transformed engagement behavior, reduced hesitation, and elevated operational confidence across armored units. The 90mm gun also left a lasting imprint on armored doctrine and weapons development. Post-war tanks, including the M26 Pershing and M48 Patton, incorporated high-velocity main guns designed with the explicit intent of defeating heavy armor at range. Engineering practices established during the gun's development, systematic testing, iterative refinement, and integration with industrial mass production became standard for future American armored vehicle programs. The lessons of focused innovation, reliability under combat conditions, and alignment of design with tactical reality persisted well beyond the European theatre. Reflecting on the broader implications, the story of the 90mm gun illustrates a fundamental principle of warfare and engineering. Advantage is rarely absolute. Fear, reputation, and technical complexity may confer temporary dominance, but disciplined, targeted solutions can overturn even the most formidable assumptions. The Tiger, a machine designed to inspire awe and project invincibility, fell not to massed fire, overwhelming numbers, or heroic individual action, but to the methodical application of precise engineering aligned with production and doctrine. It is a lesson as much about human ingenuity and problem-solving as it is about technology. In the final analysis, the 90mm gun represents a convergence of multiple elements: technical mastery, industrial capacity, tactical foresight, and psychological insight. Its success was not accidental. It was the product of meticulous design, rigorous testing, and the disciplined integration of engineering into operational reality. It reshaped the battlefield, diminished the myth of invincibility surrounding German heavy tanks, and empowered American forces to act with confidence where once caution had dominated. The legacy of the weapon, like that of other pivotal innovations of the Second World War, extends far beyond the immediate conflict. It demonstrates that the decisive factor in warfare is often the application of knowledge, not simply the accumulation of machines. It underscores the human dimension of technological triumph, the engineers, technicians, and soldiers who understood, implemented, and wielded the innovation. And it exemplifies a core truth of military history. The most feared adversary can be neutralized when ingenuity is applied with precision, persistence, and purpose. As historians, engineers, and military planners look back on the European campaigns of 1944 and 1945, the 90mm gun remains emblematic of this lesson. It is a testament to the power of focused design, empirical rigor, and the disciplined application of human intelligence to solve seemingly impossible problems. The Tiger tank, a symbol of engineering pride and battlefield dominance, was undone not by chance or brute force, but by a weapon conceived, tested, and deployed with methodical certainty. In the end, the story of the 90mm gun is as much about the human capacity for problem-solving as it is about steel and gunpowder. It reminds us that even in the most chaotic and violent of conflicts, clarity of purpose, disciplined engineering, and unwavering focus on the decisive variable can redefine the outcome. The Tiger, once the embodiment of armored invincibility, serves as a monument not to failure, but to the transformative power of human ingenuity applied with precision. And so, the final chapter of this story closes with a paradox both profound and instructive. A weapon designed to destroy a machine came to illuminate the enduring truth that in war, as in life, mastery over complexity and the courage to focus on what truly matters can overturn the most formidable obstacles. In the forests of Europe, along the roads and hedgerows where tigers once ruled, it was not numbers, not intimidation, nor sheer will that prevailed. It was the calculated, resolute intelligence behind a 90mm gun. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.